Hey class, my day is getting a little crazy, so I have asked my friend Professor Pumpernickel to go ahead and do this video for me. She is an expert at ratios, and so she will do great teaching you about them. So please listen attentively and make sure you're taking notes. She'll tell you the places where you need to take notes. And I hope you learn so much about ratios. Bye! Hello, this thing on? Oh, yes, there we go, it's recording, I see it now. Hello, my name is Professor Pumpernickel, and, Mrs. McNutt has asked me to teach you about ratios, because I don't like to brag, but I am, in fact, an expert about ratios. So, I hope you enjoy this. I don't do things like this very often, but, it should be fantastic, so, let's go. How do I turn it off? Oh, the button? Okay. Okay, yes, now. So, children, let's start with the definition of ratio. Please write this down in your notebooks. Anytime I or Mrs. McNutt writes a word down with the definition, you should write it in your notebook. So here we go. The definition of ratio is it is the comparison between two quantities. Yes, any two quantities, when you make a comparison, that is a ratio. If you need to pause the video to write that down, you can do that. That is a great strategy to make sure you don't miss anything. Okay, now, ratios can be written in a few different ways. You saw all three of the ways on your pretest, I believe, is what Mrs. McNutt told me. So, you can either write it with a colon, and it looks something like this, like 3 to 2 with a colon, or you can write it with a fraction bar. So that would, if I use the same numbers, 3 over 2. Yes, there's that one. Or you can use the word 2. So 3, 2, 2, 2, like a ballerina. Okay, moving on. Now, if I were to ask you, what is the ratio of blue dots to red dots? Your pretest showed Mrs. McNutt that you could already tell us that there are 3 red dots and 3 blue dots and 2 red dots, that you already knew how to write that ratio, and that is terrific. But there are a few things that I want to point out about ratios, just in case you missed them. The first thing is that the category that is written or stated first needs to come first in your ratio. So what that means is, if I say, please tell me the ratio of blue dots to red dots, this is correct. That's very, very good. But if you told me, oh, the ratio of blue dots to red dots is 2 to 3, those are the correct numbers, but they are in the incorrect order. Order matters in a ratio. You have to keep it correct. Okay. Now, the second one I will do on the next slide. Okay, the second thing that's very important, Mrs. McNutt told me that this tripped up a couple of you on your pretest. She said make sure you read the questions carefully. Now, if I ask you for the ratio of blue dots to red dots, 3 to 2 is very, very good, just like we talked about last slide. But what if I say, what is the ratio of blue dots to total dots? Yes, if you said 3 to 5, you are absolutely correct. Blue to total is 3 to 5. That's blue to total dots. Yes, good. So just make sure you are very good about reading directions. It's very important. Okay, now the last thing that Mrs. McNutt would like me to mention to you is that ratios can be simplified. That means you're breaking the numbers down and making them a little smaller and still say the same thing about the comparison between the two quantities. For instance, notice that the ratio of green stars to purple stars is 6 to 10, right? 6 to 10. Oh, that's in purple. I hope you understand it. 6 to 10. What if I were to break each group up into two different parts? So here's a group of 3 stars and a group of 3 green stars. And then here, let's pull these purple stars down. Oh, look, 5 and 5. Okay, now, if we look up here above this line, now our ratio of green to purple stars is 3 to 5. And down here, what's our ratio? Oh, 3 to 5. Okay, so we find out that 3 to 5 is the simplified ratio for 6 to 10. And any ratio with different numbers that still shows the same comparison is called an equivalent ratio. I will give you that definition on the next slide because you need to write it down. Okay, here is the definition. You can write that down. You may need to pause the video. Okay, now Miss McNutt just called me and she said, Professor Pumpernickel, you don't understand. These kids are very, very smart. They can pick up on things so quickly. You need to give them more information, more to learn, so they can practice more stuff because they are so fast. You will not believe how fast they are. So, she has already emailed you an IXL lesson for you to do by yourself, and then everybody will do this lesson too, about ratio tables. So let me explain to you ratio tables. In a ratio table, every row is its own ratio. So this row right here is going to be its own ratio. And then this row is a ratio, this row is a ratio, this row, and so on and so forth. So here we've started off with a ratio right here, 4 to 6. Now we don't know the story behind these ratios. We don't know anything about them, just this 4 and this 6, that's all. But that's okay, that's enough to complete the table. So if we start off with a 4 here and a 6 here, well, what happened? How do we fill in this box right here? Well, we can say, well, what's the comparison between 4 and 2? Well, when we go from 4 to 2, we divide by 2, right? So if we divide by 2 to get from 4 to 2, we're going to divide by 2 to get from 6 to this box, right? When we divide 6 by 2, we get 3. Ah, that's beautiful. Yes. Good job. I can tell some of you were thinking that as I was saying it. Now, moving right along. How do we get from 4 and 6 to something and 9? Now, that honestly might be pretty difficult to do, but we have already established a second ratio. We also have 2 to 3. So what if instead of using 4 to 6, we use 2 to 3? And apply it down here. We can go from 3 to 9 by multiplying by 3. So we will do the same thing here. 2 times 3 gives us 6. Very, very good. Now, you can use either this ratio or this ratio to help you complete this ratio. I'm going to use 4 to 6. I just picked that one. You can use this one if you want to. But if we use 4 to 6, we see that 4 times 2 would give us 8. So we must use the same multiplication here. 6 times 2 gives us, that's right, 12. Okay? Now, I'm going to give you a few minutes to think about how the rest of the table would get completed. Actually, I'm going to give you 30 seconds. Ready, go. All right, did you come up with the answers? If you said 12 for this box, you are correct. And if you said 30 for this box, you are also correct. If you did not get those numbers, remember, PS1, stick with it and figure it out. Ask a friend, ask a teacher, but figure it out. It has been so great teaching you today. I hope you have a great time with ratios. Bye-bye from Professor Pumpernickel.